Okay, looking at our review again, please try this on your own first. Which postulate or theorem? We see we have a shared side, so that's going to be side angle side. Let's see here. Over here it looks like we have an angle, and a side. Shared side, which gives us side, side, side. This is the example of angle, side. You might want to say hypotenuse leg, but again, in this case, we actually don't know the hypotenuse. The hypotenuse is across from 90, and we don't know anything about that. We do know angle, side, though. This looks like angle, side as well. If you had to name the congruency, if you had to name the triangle, again, the order matters. So, for example, if I were to do this one, I would do angle A, angle T, angle S. So triangle ATS is congruent. And then I would have to do CBA. So again, if you have to name something, make sure you're using the correct order. Let's see here. There's lots of triangles in this one. I would say that if we were going to look at this triangle here and this triangle here, we could say that we have two angles in the triangle, and then we would have to use angle addition postulate, but we could prove that that other side is congruent. So I would say angle, side, angle with after using the angle addition postulate if we had to prove it. This, because it's a shared side, is the example of hypotenuse leg, hypotenuse and leg. And over here, it looks like we have one angle that is congruent. We've got parallel lines. These are not perpendicular lines. So if this was parallel and this was parallel, I could call this my transversal, which means this angle and this angle are in the same corresponding location. So we could use corresponding angles are congruent, which gives me angle, side, angle because of corresponding angles. Complete the proof. AB is congruent to CB, given. D is the midpoint of AC, also given. But I should mark that. Again, I strongly recommend you write stuff out, you mark stuff up. AD is congruent to CD by the definition of midpoint. BD is congruent to BD by the reflexive property. And then this looks like side, side, side to me. Again, always start with your givens. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Prove MNQ is congruent to QPM. So immediately I already see that in triangle, in my triangle MNQ, so let's see what our statement is. This is already kind of filled out for you. Angle 3 and angle 5 are supplementary. That's true. They're adjacent and they make a straight line. Angle 4 and angle 6 are supplementary. Angle 5 is congruent to angle 6 by the congruent supplements theorem. Again, also basically just saying, hey, whatever this is and whatever this is the same. So if it has to equal 180, I can add angle 5 or I can add angle 6. It will still equal the same thing because they have to add up to 180. And then we notice that M and Q is actually used in the same triangle. So this is the reflexive property because M and Q is shared as a shared side. So it looks like to me we have an example of, let's see here, angle, side. Angle, side. The yellow triangle has, well, so the yellow triangle has angle, side, angle. So we could again prove this multiple ways. There's multiple ways you can prove this one. But given what we were working with here, this is what we're going to go with. All right, couple more. QS is congruent to PR. So that's this right here. All right, that's given. PS is perpendicular to RS. So that means 90 degrees. QR is perpendicular to RS. So again, we've got 90 degrees. Angle S and angle R are right triangles. That's just are right angles. That's just, again, definition of a right triangle or definition of a perpendicular angle. Triangle PRS and triangle QRS are right triangles because they have a base of 90 degrees. Okay. RS is congruent to SR. That's the symmetric property. I can switch the order around and it's still going to equal each other. Therefore, PRS is congruent to QSR. So let's highlight our triangles. Triangle PRS is congruent to triangle QSR by the hypotenuse leg theorem. Okay, we found that the hypotenuse across from 90 was congruent and the leg next to 90 was congruent. This one, it's up to you. Write a proof. BE is congruent to BC. I'm going to start with my givens. Angle A is congruent to angle D. It's already marked. If it wasn't marked, I would mark it. I'm going to see that, hey, I've got something going on here. I'm going to say that angle ABE is congruent to angle DBC by the vertical angles theorem. And so if this equals this, I have angle, side. So therefore, triangle ABE is congruent to triangle DBC by angle, side. Start with your givens. If it's not marked, mark it. ZX bisects this angle, which means cuts it in half. So this is congruent to this. So that is the definition of a bisector. The word bisect means to cut in half. XZ is congruent to XC. That's the reflexive property. And if I'm looking at my triangles, WXZ and YXZ
XZ and WXZ. They share a side, which is why I used reflexive. So this is going to give me side angle side. And then to prove what the question asked me to prove, the question wanted me to prove this, which is right here and right here. That's corresponding parts of congruent triangles are congruent. Last example, prove Mn is congruent to Tq. Okay, well, I see that for starters, Mq is congruent to Nt, that's given, and Mq is parallel to Nt, also given. Again, the difference, this is parallel, the other line is congruent. I'm going to state that here's my triangles that I'm looking at. I'm looking at MNT and I am looking at MQT. So I'm going to say that MT is congruent to MT by the reflexive property. So as I look at these parallel lines, I know that they extend forever. And then I can pretend that MT is a transversal. So if I look at this, and I'll highlight it here, I see that I have an angle right here and an angle right here, which, if we can remember, two parallel lines cut by a transversal that are on opposite sides but inside of our parallel lines, we call that alternate interior angles. So I can say that angle QMT is congruent to angle NTM by alternate interior angles, which, when we look at our finished product, I've got a side, an angle, and a side. A side, an angle, and a side. So we can say that triangle NTM is congruent to triangle QMT by side, angle, side. And then to prove what the question asks, we can say that MN is congruent to TQ by CPCTC. Corresponding parts of congruent triangles are congruent.